Section 6.1, Operations with Polynomials. When you're multiplying variables, you add the exponents. Quotient of powers, when you divide variables, you subtract the exponents. When you have a negative exponent, you have to move the base down to the bottom to make it a positive exponent. If you have the base in the bottom with a negative exponent, you need to move it up top to make it a positive exponent. When you have a power of a power, you multiply the exponents. Anything to the 0 power is 1. 7 to the 0 power is 1. 3ab, all to the 0 power is 1. But in the very last example, notice that it's just b to the 0 power, so it's 3a times 1, which is 3a. Look over this. A monomial expression is simplified when there's no power of powers, each base appears exactly once, all fractions are simplified, and no negative exponents. Now we have to make everything positive. Don't get the negative 14 confused with the negative exponent. That does not mean it's a negative exponent. Just the negative 3, y to the negative third is a negative exponent. Now there's two ways you could do f. You could flip it, or simplify inside and then flip it, or you could flip it, and then when you have a 1, that doesn't change anything. Determine whether each expression of a polynomial if it is a polynomial, state the degree. Remember, the degree is the variables with the highest exponent. So the first term has an exponent of 7 because we're going to add 4 plus 3. And the second term has an exponent, a degree of 5. So yes, it is a polynomial and the degree is 7. Example B is not because of the square root of x. Example C is not because you cannot have variables in the denominator. And example D is, and the degree is 7. When we're adding or subtracting polynomials, we have to clear the parentheses. In the second parentheses is a negative, so we had to distribute the negative. But in the first parentheses, it was just a positive, so you just dropped it down, rewrote it without the plus sign. And then we're going to combine like terms. Example B, we have to just rewrite the polynomials without the parentheses. There's both positive signs in front, so we just drop the parentheses. And then combine like terms. Example C, drop the first parentheses, copy it down as is. The second parentheses, we have to distribute the negative out. Then combine like terms. We have to distribute the 3x to everything. After we distribute, we try to combine like terms. We can't, So we're done. Example B, we're going to multiply everything by 4/3 x squared. In example 6, we have to multiply the n squared times each term in the binomial. Then we multiply 4n times each term. Then we multiply -6 times each term in the binomial. Combine like terms, and always combine them and put them in descending order. Combine like terms. In example D, I'm going to rewrite that to say 2x minus 2y quantity squared times 2x minus 2y. Then I'm going to multiply the quantity squared. There's a shortcut. You square the first term, multiply the two terms together, and then double it. So when you multiply 2x times a -2y, you get a -4xy. Double it, you get -8xy. Then square the last term, and you get positive 4y squared. Then we're going to multiply by the 2x minus 2y. Number 43, I'm going to show you two different ways you could do 43.
Hi, Scott, how are you?
I'm going to do power of a power, and then make all of my exponents positive. I move the x to the -4, move it up top, move the y to the -8 up bottom, then combine like terms, or multiply variables together by adding the exponents. Another way to do this is to make the outside positive. Oh no, I distributed it. And then make everything positive. Then multiply my variables together by adding the exponents.
Christmas lights?
And number 45, I have to make that second parentheses a positive exponent by moving it down in the bottom. And then I'm going to divide the variables, and you can finish the rest. And that is the end of section 6.1.